Good evening, everyone. So here we are live with our Python basic tutorial again. We'll begin with all that we have done till now. We'll revise those things. So in the last class, I have taught you about how Python works, what strings are, what data types are used. We had a lot of things done in last part. Comments समझ लिया था हमने. We did about comments, data types हो चुके थे, numbers, strings, booleans, all those things were all done. Okay, so true and false are the booleans. If you are not sure, we provide the value of 0 and 1, where 1 is the true and 0 is the false value for boolean. In Python, boolean actually returns 0 or 1 only. They do not return a true or false. They return either a 0 or a 1 in boolean format. Okay, whereas in other languages, if you see, for example, JavaScript, if you take JavaScript, returns true for true and false for false. But there is nothing like that in Python. Python returns either a 0 or a 1. Anything that you want. You can even change your conditions for true and false and without returning. We'll talk about statements, we'll talk about conditions, but before we begin with that, we'll start with list, tuple, and dictionary as well. We'll understand what list looks like, what dictionary looks like. These are some of the data structures that we have in Python. So we'll start with list. Let me show you my screen right here. I'll put up my screen and then we'll begin with the basic coding. Okay, so right here we have our integrated environment. Hope that you all can see this environment right here. So today we'll start with a list part. Okay, for example, if we define list, the list is defined in a square bracket. Okay, the list is basically defined in a square bracket. And for example that we have seen in the previous classes as earlier, is that if we write anything inside a double quotations, for example if we write the page right here, then it is a string, list that contains string. And then Pandey, we can also use multiple string types. For example, this is the string type of list, which will hold the values of string. There is no character type, as I told you in the previous class. So this is string type. We'll have these placement Gurukul. Okay, this is a string of list. Suppose we named it as S list. Okay, and then we can also have a list of numbers. For example, if we have n list is equal to, in square brackets, every square bracket will represent a list for sure. We can have 1 comma 2 comma 3 comma 4, something like this. This is a list of numbers. We can have a hybrid list as well. For example, ns list equals, in square bracket we can have the string, and we can have a number as well. Okay, so this will be used like this. Now when I talk about number, I do not only talk about integer. This can be 5.0 as a float as well. You can take a double value also. You can take a double float value, double integer value, anything that you want. List gives you this entire facility of using different types of data, different data types into a single list as well, or a list of similar data types as well. Okay, so now as usual we can print the S list, and we can print the N list, and we can also print the NS list as usual, which will provide you with all that we have in our list right now. So if we run this entire thing, you can see that we have a list which had the string type, then we have a number list, and then we have a list of a number and string together. Fine. This is how a list works for you. Now, let us also talk about how the functions are used. So in a list, we have a number of functions. We have dot append function. Will not be doing in our practical sessions right here. This is just the basic tutorial, so I'll be making you aware about all those, the functions which are pre-defined inside Python. For example, we have one function called append. This will add up the value into the same list. We have a clear function as well, which will clear the data. A copy function we have. And as you know about the data structures, there are also pop function. If there is an append function, there will be also a pop function. So these are all the functions that we have in our Python. We can use it. There are a variety of a list. I'll be providing you in your group later on about the list of all those functions that we can use. Another way is, suppose you have something like ABC is equal to Dipesh, comma, code, code. Now, if you have something like this, what you will get is, when you will print type for ABS, at that particular moment of time, if I run this code, you will get a tuple, right? So now this data type in a parenthesis is a tuple data type, right? This is a tuple data type. What tuple data type is? It is a referential number indexed. Okay, so referential number indexed type of value, which is tuple. When you define something in a square bracket, to make sure if there is a square bracket, it's a list. For an instance, this is the list. Then if you have something in a parenthesis, you will have it as a tuple. And if you have something in a curly brace, right, like this, that will be considered as the dictionary. Okay, so these are different methods of representing how data type is. Now, as I told you, the typecasting in the earlier class also, there is a facility of typecasting very frequently. So now, if I convert this entire thing, this entire tuple into a list, I'll be doing it like, suppose there is a list variable, and then we also have a function called list. Now, what this list will do is, this list will convert this entire tuple into a list. So if we print the type for a list variable, then what we get here is a list. Now the type of data which is inside this variable is a list data type, and what's inside ABS is a tuple data type. So we have a tuple right here and we have a list right here. This is called typecasting. We change the data type of one particular variable into a different variable by this method, right? Now, in when we talk about tuples, we also have particular functions and all the attributes right here, as you can see in different ways. Also, you can check it on your own about the functions that we have. I'll send the list of all the possible switch offers. For example, we have a count function which will return the values of how many data is inside this, how many objects are inside a tuple. Okay, then we can get the index also, index of particular data. For example, if I want the index of the page, what the index is, then we'll have it with a function called index. We have a function called index. Okay, these are the advanced things which we'll be learning in the later classes. This is how the list is defined and how the tuples can be defined. So the tuple is defined inside a parenthesis, and then this tuple can be typecasted inside a list. Furthermore, there is a set, or if you say in a parenthesis bracket, for example, if you define something as ABS is equal to like this, then this is a set. I know you must be confused about what I wrote earlier. I wrote that in a curly braces, this is a dictionary data type, right? But then dictionary data type also holds some other methodologies as well. For example, not just a curly brace represents a dictionary data type, but there are also many other parameters, which I'll be telling you after a few moments. For example, if this we have in curly braces, then this is a set data type. Okay, so we'll get it as a set data type. Now if you want to convert this entire set into a dictionary, you can do it as like this. 1. Now this is a dictionary data type. 1 second, I'll show you. 2. Now this is a dictionary data type. Fine. In a set data type, what we had was, suppose 1 comma 2 comma 3. Okay, this is a set data type. This data type is set for in curly braces. Now this also holds many other functionalities that we offer. For example, the copy functionalities, the differences. We can calculate the difference between all the elements that is present inside a set. We can use discard functions. We can use intersection. We can use other functionalities. For example, if we want to get a subset, for instance, you must have read in mathematics also about set. So it's quite similar. Whatever functions we used to have in our uh, set chapter of mathematics, that all we have here is set of is a subset or not. So these are all the functionalities that we have. They provide you with a boolean data type. For example, if you use a is uppercase, for example, if you have this entire set with characters with a string variable, okay, so now if you want to get is this is a set, this is uppercase, then if you print this entire value, for example, the set dot is set is upper. Okay, so this is also a functionality which will provide you with some particular values. Okay, this will return a boolean type of value to you. Also, if you have two different sets, then you can use for a disjoint set if you want to check if your values accordingly. Similarly, we also have a dictionary data type. I am here to make you familiar with all those data types only. So what we also have is a dictionary data type. In dictionary, what we have is we have a key and a value pair. In dictionary, a curly braces is required to mark it as a dictionary format, dictionary data type. And also to make it a dictionary data type, we also should have a key and a value. So what we have is inside a dictionary, there is a key is to value pair. This complete thing makes it a dictionary. Okay, I'm really sorry for this. So this makes a complete dictionary, a pair of key and a value provided along with the same side. Now what we have next is, if you are clear with this, let us see what we have in our comment sections as well. Okay, so we are clear with the comment sections right now. Fine. Is there any question that you want to ask regarding this data types? We have a lot of data type sets provided right here. We have list, dictionary, set, and also the tuple. Fine, we won't be wasting time. We'll come with conditions now. So in conditions, what we have is if else condition, as the methodology has come since very far, since C language. So we have an if else statement, and we also have a while loop. We must have done, you must have done it in earlier classes as well. So what a if else statement looks like is, if is a keyword and else is also a keyword. Let me come to my console, back to my editor. Okay, so this is my editor right here. Wait a second. Fine, I'll get this editor right here. Till now we have seen the data structures right here. Now in if else statement, what we have is, if is a keyword which will take some condition and will create a scope, and we'll have a set of functions running here, right? There will be some stuff written right here, and then if this is true, if the condition is satisfied, we'll run this. Else we'll be running another set of data. Now in this particular statement, the very frequently used part is a pass keyword. Pass keyword does is, it won't execute anything, but it ends up the current iteration. It exits the current iteration. Now you must be clear about what iteration is, which I'll be telling you when we'll be learning about loops. This is the conditional actually. So in condition we have a pass keyword also, which we will be using very frequently. Now let us begin with some codes. If suppose we have a value A is equal to 20 and B is equal to 13. Now what the condition is, if in parentheses A modulo B, print, suppose we want to print the current value A modulo B, else what we'll be doing is we'll print not valid. So in this particular condition, A modulo B will not return any value. For instance, if we run this particular code, what we get is 7. So this was true if this would have returned 0. For example, if this current operation A modulo B will return some value, it will return a particular, it will run a particular stuff, a particular snippet, a code which will be required on running for if statement. Now let us check if conditions are operated. For example, if A equals 20, this is an equals operation. Okay, this is the comparison operator. Equals here is a comparison operator. Okay, let me make this all clear. So A equals 20. This is a comparison operator. This will compare the value of A with 20. So now if this A is equals 20, then what we want to represent is, we want to say that A in a string, obviously A is equal to 20. Else if it is not so, we'll be representing A is not equals, A is not equals 20. Fine. So this is like this. Now since A is equal to 20 as we have defined it earlier, so this is running the if part. Now let us check if it is running the B part. What we do is, if A equals B, then we'll be returning A is equal to B. Else we'll be returning A is not equal to B. Fine. This is B. Now in this particular condition, what we does is we return if A, that is the value of 20, is equal to the value of B, which is 13 right here. Okay. So if A is B, A is equal to the value of B, we'll be returning a particular string, a particular message you can say, else this. So in this particular scenario, we'll be running the else statement. So now else part is executed. Why? Because if part has not returned a true value. Okay. And now if you want to run the same, you can use a not equal to function as well. Now what this represents is an exclamation sign, and an equal to represents not equal to. So this particular snippet is about A not equals to B. So here A is not equal to B, then it will represent A is not equal B, and here it will represent A is B, right? So in this particular part, what we are running, when we run this code, we get A is not equal to B, which is the if part. Here you understand how the not equal to sign works, right? We got the same result in both our scenarios, but the difference is in this particular scenario, the if part is executed, and in the earlier one, the else part was executed, right? Other also, to make it clear, with A equals B is the comparison part. Okay, then we have A not equal to B. Okay, A not equal to B. We also can use the A greater than B part, or all the other comparative signatures. Okay, this is like that. And then there's also a symbol called A greater than or equal to B. Fine. This will check if A is either greater than B or is equal to B. Fine. We have these few of the workings, how it is performed, and in the further parts you can execute also according to your wishes. Now this was all about the if else statement. This was one of the conditional. Now the other conditional is while loop. Okay, So what while loop does is it checks for a condition first and then executes a particular set of code. For instance, suppose I is equal to 10. Okay, now here, let me take you to the interesting factor right here, which I was about to explain in the previous if else part also, but you can understand from here as well. I'll be explaining Boolean also in this particular, how you can use Booleans to control the conditions. Okay, so here what we have is I equals 10. Now let us check while I is greater than 1 or greater than 0, for instance. Okay, if I is greater than, if I is greater than 0, if I is greater than 0, then we want to print is I greater than, I is greater than 0, right? We want to return this part. So here if we run, what we get is I is greater than 0. Fine. Now, what you see here is we get the output continuously. Why? Because there is no break statement or there is no method mechanism explained right here for breaking out of this loop, right? 1 second. For I'm really sorry for this interaction. Uh, for some other network issues. Fine. So what we here was doing is while I is greater than 0, this starts checking the value I is 10. Now until and unless this condition will be declined, जब तक ये condition false नहीं हो जाता, until and unless this particular condition will return a false value, this entire statement will continue to execute. That was the reason why we used to get this entire thing. Now this will go into an infinite loop. What happens is infinite loop will be executed right here. Okay. To avoid this part, what we do is we'll use up some other values. I equals I minus 1. Fine. And let us decrease also this. So we have this 4. Now, if we run this particular code snippet, what we get here is 4 times 0. Why? Because it will, at the very initial stage, it will have a value of I is equal to 4. It will go with while I is greater than 0, right? I is greater than 0. The condition is true. It will run this code and print I is greater than 0, and then it will run I minus 1. Now this value will be decreased to 3. In the next iteration, when it comes, it will check I is greater than 0 because current value of I is 3, which is obviously greater than 0. It will execute the same part and will decrease the value of 3 to 2. Now again the while loop will be executed. This will check the condition whether I is greater than 0, which is obviously the current value is 2. It will execute the same statement and it will go to 1. The way at the point when it comes to 0, it will check the value I greater than 0 and the condition will be returned as false. Fine. So this false will be stopping, this will break this entire loop, and these all statements will not be executed further. Now what happens here is, see, I'll be telling you, to avoid this statement we also have a method. As I told you earlier, there is something called boolean. Okay, now we do not have any value right here. What we have is while 1. Now while 1 does while true, while 1 is while true. When we run, what we get, okay, I here is an issue, it should be removed. Okay, so when we do while I, it will start an infinite loop. Why? Because this loop is true, this condition is true, that we have provided a particular fixed true value while 1. It will run it. Now let us stop this, and if we pass the boolean value 0, which is false. Now 0 here stands for false. When it will encounter while false, it won't execute this particular thing. Why? because anything inside this parenthesis must be a true value, whereas 0 is a false value. Okay, 0 is a false value, 1 is a true value. So in these conditions, we have these executed. Now, this particular snippet will also be running. What it will do is, while suppose we have something like I equals something. This is 1, this should be I. Okay, I. Now what I holds is a string value. There is something, obviously either a garbage value or something, but it has something, right? So when we run it as while I'm sorry for this. Okay. So when we will run while I, it will print, it should print while I. Okay. So while I, what we have here is when we ask for while I, now I holds some value, which means this will return a true value because there is something inside I. I holds a string. While I means while there is true, then it will start to execute this. Now if I is an empty string, see, this is an empty string. If there is an empty string, for sure there is no value inside it, as sure as possible. Now we run this, it will return a false right here, and the while loop will be terminated instantly, right? This was how the while loop works. Now let us move to the next one, for loop. For loop is an interesting thing. Why? Because for loop is an iterative part. So it iterates over a sequence of either a string, a list, a tuple, or anything like that. Okay, it will start to operate over a particular set of data. For example, for what the syntax here is, for I in range, this is the syntax 0 comma 1 comma 10 comma plus 1 print I. Okay, now I must be defined right here. Suppose I is 0, I is 1, I guess. If it is 1, it will start from here and will print you 1 to 1 to 9, right? Why? Because in this statement, this is the keyword for. I is the value which will be iterated, and the value of I must be in a range of an initial value 1. The very first argument of this particular parenthesis is the initial value, the final value, and the increment. This also can be written as -1. Okay, so it will start decreasing it. Now the good part here is, which you must have seen, we do not have 10 here, but we had a range of 1 to 10. So in a for value in Python, in every range, what we have, the initial value is accepted, but the outer bound value is never accepted. For example, this will always run from 1 to 9 only. It will never reach 10 in any condition. If we have it here 11, then it will print up to 1 to 10. Okay, so here you can see you have 10 as well. What it does is it always reaches to the outer bound but never executes the actual outer bound value, right? This is how it works. Now let us also make some clear effects for other values. Now suppose you can also do one thing. A is equal to, suppose we have placement Gurukul, right? Now in for loop, the interesting thing is we can do is for I in A, print I. What this entire code will do is, it will take a value I. Now this I will be iterated all over A. For example, A here is a string. It will be sliced and I will hold a value P, then L, then A, then C, then E, then M, and so on, right? I will always hold a value from this A, which is a string, and then it will start to execute. For example, if we print it, what we get here is, we get every single alphabet of this particular string. Why? Because this has got iterated iterated from index 0 to index len minus 1. Fine. The entire stuff is iterated. Now other thing what you can do is, see, dot split. If you, there was a function which I told you in the last class, which is split. If a, for I in a dot split, print I. Now what we got is placement and Gurukul. Why it happened is, let me tell you, this was the short way. Let me take it to a different variable b, and b is equal to a dot split. So dot split function does is, it will split this entire string into two parts from this particular space. If you haven't provided any argument right here, because if there is an argument, then this entire thing will be splitted over that value, and if there isn't anyone, it will take space by default. So by default value is a space. So this will return, this will have created a list where the first argument, first value will be placement, and the second value will be Gurukul. Okay, so what I holds right now is, I holds placement and I holds Gurukul, because now it is, this I is iterating over this entire list. Okay, so this entire list will be iterated for I. Now suppose s equals a dot split, which I was talking about argument is, in an argument, if you start doing it with, suppose what we have the maximum number of times is, we have u in Gurukul, right? Suppose we change it to Gurukul, that's it. Now what we have most number of times is u, and what we want is everything except u. So what we'll do it, if we split it over u, then what we'll be getting in return, let us also print this s, so you can see what we are getting actually. See, when we have splitted this entire a with u as an argument, what we got is everything before and after u is taken. It has splitted this entire string over u. Now over u, which means is, we'll have g but we'll not have u, we'll have r but we'll not have u, we'll have k but not u, and l but not anything after l. So what we have a list of all those alphabets. To make you clear, if there was something like G, A, B, C, then our first element of the list will become this. This entire thing will be our first element. For example, like this. Okay. Whenever it will encounter a U, it will break it into a next element of the list. Everything which, every time we encounter U, we'll get a new list element. So what we here have is Gurukul, like this. Okay. Now if we start iterating over S, we'll get every single element of right here. See, what we have is every single element of the list, which is splitted over U. Okay, so this is how the loop function works, and this is how you can like use it for use it along with split also. This is how it works. Now let us check for some questions. Is there anything? So this is okay. Let me remove this entire section, my current screen. Current screen. Okay, fine. This will be removed in a while. Fine. Sir, this is my first day. Have you already taught list, set, and tuple? No, I haven't taught about list, set, and tuple. But what we had was we had a quick session today, and we had some introductory part about list in the previous class. You can check out the entire playlist on YouTube of the same channel, Placement Gurukul. You can check out them and you can attend those lectures as well. It's not an issue. Okay, and I haven't taught anything earlier. It was all in this current session. A brief introduction was given, and the entire dynamic introduction and the programs will be made when we will be in the Python masterclass, which will be running hopefully after 15th of August. We'll start the new batch from 15th August as a tribute for Independence Day. So we'll be having it from 15th of August onwards. You will be notified about it. Okay. So we'll be running from there. Fine. And I request you all to please fill up the attendance link as well. And I'll now start with functions. Let me show you my screen. Okay. Now we have been talking about functions a lot of time, right? Like that split is a function, print is a function, dot list is a function, dot tuple is a function, something like this. We have talked a lot of times. Now what things that matter is how we can create our own functions, right? Till now we have used a predefined functions. Now we'll be defining our own function. So def is a keyword. Def is a keyword which is used for defining a function. Fine. We'll define a function. Now the function name is given. The syntax for using a def keyword is def as a keyword, and the name of function, suppose it is function. No, this is already a reserved keyword. Suppose there is a function for add. Okay. So what we had is addition as a function. And inside addition, what we'll do is we'll have a value a is equal to a is equal to 20, b is equal to 30, and then we'll print both addition values right here. Okay, so this is all that function is created. Now if we call this entire function, how we call is addition and parentheses. Okay, so this will call up the function, and then we'll have the resultant value right here. 50 is the addition for this entire value. Another method of using print is we can return the value. Okay, instead of this we can use the keyword return a plus b. And now if we print addition, if we execute this command, this particular function, if we call this function, we will not have anything on our screen. Why? Because there is nothing to print on the screen. We haven't written any command to print. But this return holds a value, obviously, which we can check from here. If you print the value which is returned from addition, we'll get the required value. Now we get 50. Why we get 50 is because this function has returned a value, and that value is being printed by this particular function. Okay, so this is how we use a function. This is how we define a function. Either we'll use a print statement inside a function or a return statement. To mark my words, only one single return will be executed, and there won't be anything later on executed. Suppose what we have is print after return. Now, if we run this command, we won't be getting a print statement executed. Why? Because anything written after return statement, return function, and this statement is not executed anytime in this entire life cycle. The Python's life cycle of a function exits with a return value, right? After return, there won't be anything which is executed. Instead, if this entire print function is above this particular value, then it will obviously before it is. If it is before this, then we'll have it executed, and we'll have return also executed. So anything after print will be executed, but anything after return will not be executed. Suppose this is right here. What I wanted to make clear you all is anything after return will never be executed. So the before return part will be executed, but after return part will not be executed in any manner, right? Are we clear from here? Great. Now this was how we can create a function. Now we can also have an argumented function. What argumented function is, we can, like we had addition right here. Okay, so what we had was addition. Let me decrease it. Okay, we did not have any argument with the function, but when we used earlier, we also had functions which hold some argument, which asks for some argument. So in this particular thing, we can have an argumented function as well. What we'll provide is a comma b. Now this function will ask for two arguments, which is a and which is b. Now we can remove it from here. We can remove this entire code as well, and also this code. So now we can directly add up a and b. So if we run this particular thing, we'll be having an error. Now this error is, what we got, the error is missing two required positions a and b. Why? Because this particular function is called but is not provided with any value. So here what we can do is, we can provide the value 20 comma 30. Now this function holds two values for the argument a comma b. Now 20 will be assigned to a and 30 will be assigned to b. Okay, you can also see if we print a comma b, what we have is, we run it, we have a comma b. So a holds the value 20 and b holds the value 30, and 50 is the addition which is returned. Now to make clear to you all, the entire value which we provide inside a function is assigned to the parameters in a sequential manner, that is first come first serve. So if 20 comes first, 20 is assigned. If 30 comes first, 30 is assigned. So if you want to assign 30 to a, we need to write 30 right here. Now other method to do this is, we can write b is equal to 20 comma a is equal to 30. Fine. If we do it right like this, what we get is, now a is assigned 30, but it is already written in the second argument, but it has to be written in the first argument. But what we did was, we have assigned it along with the keywords, along with the variable names. So we have reformatted the entire section and given a value according to the argument required. So b is given value 20 and a is given value 30. Now there is also some parameterized values, like if a is equal to 30 is given, we need not to provide the value of a. We can simply provide the value of 30 and, okay, non-default value followed right here. Okay, fine, my mistake, follows the default argument. So this is a non-default value which has to be 0. It must be defined some or the other way. So if you have defined one of the value with some one of the argument with some value, you must also define all the other one with some values. Okay, or you can also have one very important keyword is null. Okay, so null keyword is also used. Now this is how we have we can have the values to the parameters, we can have the values to the arguments, or we can have the argumented functions written, or we can have a simple function written without any argument further, right? These are the method that you can use. In the further part is, we can have the pointers as well, but these are all the advanced topics which need some other expertise also. Now let us talk about very important thing which you may understand, may not understand if you're not familiar with Python. So Python holds a very attractive part of function for defining a function, which is called the lambda function. What we call it as a lambda function. This is an advanced topic which we must not be reading here, but I'll be telling you about the basics of it. So what lambda function has, the argument has the syntax as a keyword lambda and an argument, and also followed by the expression. Okay, so this is the syntax for a lambda function. Now how we can use it is, suppose x is a variable which holds a function of lambda. So this will be the lambda keyword, will have an argument, suppose it is a is the argument, and then expression. Now expression here is a plus, okay, expression here is a plus 10. Fine. So now what we'll be doing here is, we'll be printing x, which was the function. Now x is the name of the function right here, and we'll have a value 5. Now what happens here is, x calls this entire function and 5 is assigned to a. Fine, a is the argument as I told you earlier, so a will have the value 5. Now if we print this entire part, we'll have 15 as our output. Why 15 is a plus 10. Now 5 plus 10 will obviously return 15. There is no great logic. So this is all about lambda function. We can have the functions in this manner also. This is an advanced topic which we'll be learning later on, not obviously in this particular class. Now furthermore, when we come, we have classes, the inheritance and other stuffs. I won't be teaching you inheritance in this basic tutorial because you won't be understanding if you aren't attending the basic one, but we'll be telling you how we define a class. So to define a class, we have a keyword named as class. Okay, now the name of class will be given. There is no parenthesis right here. So now this is the class, a is equal to something, and a class is the keyword, and my class is the name for this. Now we can here have return 10. Fine, so it can return, one second, return the value 10, or we can print the value 10. Straightforward, print 10. Okay, now if we call our class, what we have here is 10. Now to call a class, we do not need any parentheses or anything. We simply need the class name, and that class will be called. Okay, this is how it works. Now the basic thing in class is, there is always a constructor when you declare a class. Okay, now let me remove this screen so you're not distracted. I'll come back to my entire view for a second. Let me do it. I'll drop this screen, and now fine. So what happens in a class is, when we declare a class, there is a snippet of class. So along with class, there is always a constructor called. What constructor is? Constructor defines the initial values or the initial methods of how the class must run. Okay, so when we declare a class, the constructor is automatically revoked. Now if there is a class, suppose you have created a class A and you have also created a class subclass B. Okay, so inside a class A, if you have created a constructor, mind my words, there must also be a destructor defined. Fine, other cases, if you have defined one constructor in a class, there must also be a constructor in the subclass, because if the suppose a class is called, okay, and the constructor is called, is there anything issues? Okay, so if there is a constructor called and you have declared a constructor by yourself, it is not auto revoked, then in all the subclasses you will also be calling this constructor. That constructor in the subclasses will not be called by its own. Okay, so you have to call it in each and every subsequent subclass. Right, in a particular script, if you have 2-3 classes, I'm not talking about the subclass, I'm talking about the class. If you have in a particular script 2 to 3 classes, more than one classes in other words, then if you have defined in a constructor in one of the class, there must also be a constructor defined in all other classes. Why? Because if in a particular script a constructor is defined in one of the class, there won't be any other constructor auto revoked in other classes. Other classes must also have the constructors written. Okay, constructors will have an initial value which will be defined by init functions, and all other attributes will be executed accordingly. Fine. Let me give you some example. Let me bring my screen back. Okay. So here, suppose we have declared a class which is named as myself. Okay. So this is a class. Now this is the constructor in Python, which is init function. Okay. This will hold some arguments as well to provide, as we have done in our function definition. What we do is we provide some arguments, right? Similarly, in class also we can provide arguments. Suppose we have an argument of name and we have an argument of age. Fine. So we'll link this self dot name equals name and self dot age equals age. Fine. Now we'll have a function which will be revoked later on. Suppose we have a function called my name. Fine. So this will have a self argument. And now in this my name, I want to print my name only. So this will be self dot name. Fine. And suppose I also want to print my age. So there is something called my age. This is a self argument. Now we'll be printing right here about self dot age. Now what self does is, if you are familiar with the class based scripting, you must be knowing that self, or this, if you have done in something called so-called Java, if you are in Java, you must have done this, use this function, this keyword. So this keyword what does is it refers to the same class. Similarly, what self does, self refers to the values or the variables of the same class. Okay, so this is the variable of the same class myself. Okay, so self will be linked along with this. Now here we got all our functions. Now my entire class is created right here. Let me remove this console so you can see completely. So this is my class which I have defined. Now how to call a parametric class? So a parameterized class is called as, suppose class name is my class. Class name is myself, right? So this is myself dot, we can use this entire function. So first we have to initialize. Suppose a is equal to my class myself. This class is initiated along with the value of name, which is Dipesh, and another value is age. Suppose my age is 21 currently. Do not judge my age, obviously. It is 21. And don't think that I can't be good enough to teach, please. So this is my age right here. This is what we have done is we have initialized our class. The function which we wrote right here, the init function, is initialized right here now. Okay. So this function is initialized. Now if you want to get a particular part, suppose if I want to get my name only, what this entire class holds is my name and my age. If I want only my name, what we'll be doing is a dot my name, fine, a dot my name. So what I have called is, I have called this entire function, this function of, okay, so this is lost. Okay, to call a function of a class, the syntax is class dot function. So here class is defined inside this a, which is the reason why we have called as a dot my age. My age is the function and class name. So here class is defined class is defined inside a, right? So we have my age. If I run this entire code snippet, you will get only the age part. Similarly, if you also call a dot my name, then you run it, you will get the name as well. So what we get is my age, where he called first, and then my name, which is called later on. Right? This is what it is called as class. So this is a self parameter class. Fine. If you can see these things, fine. You can see this is how we have called it, and these are all the definitions what we have right here. Okay, this was all that we have done. Right. Fine. Now there are also functions which will delete a particular value from the function which may have other stuffs. So this entire class, what we call as the very first class, is called superclass or parent class. You can also change the superclass. If not defined, then this is considered as the superclass, and if defined, then other classes will be considered as a superclass. Now this is the parent class. Any other class inside it, for example, suppose this is a class A, and inside class A you have class B. Okay, so class A is the parent class, and class B, or suppose class C. Okay, class C. So these class B and class C are the children class of class A, which is parent class. So class A is parent class, and child B and child C is the children class. Okay. Similarly, if you have something called class X, then this class X is the children class of parent class B. Now parent class B is the child class of parent class A. This is called nesting of class. Inheritance of class will be taught later on. I'll be teaching you how you can use the values which are defined inside a class A, which can be used inside class B, or can be used inside class X and C as well. So this is all about inheritance of classes, which we will be taking in our later courses when we'll be doing our the master class. Okay, so these are all. Let me remove this screen. This is all defined as the basics of Python. You must be clear about what basic of Python is. Done dictionary, set, integers, strings, classes, definitions, and all other functionalities, how function is defined. Okay, so these are all the basic part which you must have learned earlier, so that we can begin with the master class of Python. Now we'll be having some of the questions from you if I get something. Why Python prints next statement in next line? Like in C++, we have used the endl to go to next line. Okay, so Ajay has a question for why print statement in Python is always printed in the next line. And as in C++, we used to have an endl type of keyword. So here, Ajay, in Python, what it does is whenever you changed one statement to other, as we have seen in the loop part, whenever Python is executing a print statement, it is taking the print statement as a new one. Okay, so whenever the new print statement is taken, it obviously changes the new line, changes the previous line to the new line. This is a predefined functionalities of Python. To avoid this thing, in Python 3.6 and 3.4 and later, we had a function keyword called endl as well, which you are talking, right? So and if you have a parameter, if you define a parameter of end, that will not change the line. Okay, which we will be also telling later on. I'll tell you afterwards. But this is how you can do. You can also avoid changing the line if you want. And by default, the line is changed because it always holds a value of end. Why B is not giving priority to 0 instead of 20? Okay, so I must have not seen this and I do not know what reference you are talking about. Why B is not why B not give priority to 0 instead of 20. So I do not know what reference you are talking, but I must, if I will be clear with the reference, if you mention it again, what the reference you are taking for B not giving priority to 0, I'll be explaining you. Okay. Now the next question is from Akash Singh. Why self is used and INIT? Okay. So now let me tell you, INIT, as I told you, you must have not listened, but INIT is the constructor which we define. Okay. It initializes the values. It initializes the basic parameters or values which a class will take. Okay, class will take. So init function is defined to get the values for a class, because you do not have any parentheses type of system for my class and then parentheses will be using. There's nothing like that for Python. So in Python we'll be having a straightforward thing, which is a class and init function which will take the arguments. Okay. Why use self? Self is used to mark that we are referring to the current class only and we are not referring to any global variable or to other classes. Okay, when we'll be learning about inheritance of Python, then we'll be telling you that how you can remove self and you can use the other class name. Okay, self here represents the parent class or the super class. And then we'll be having more than one classes and we'll be inheriting the values from other classes. Then we'll use the class name instead of self. Right? Okay, so you were talking about in functions. Okay, so 0 is not given priority because 0 is an initial value, right? So when you have an initial value and you provide a new value to it, obviously the new value is always given a priority. Fine. If you get a new cell phone in your life, you must be giving it a priority. You will be taking more care of your new phone and you won't be caring about your old phone anymore, right? This is the way how it works. That is what I'm telling. If you define a value inside a call function, when you call a function and you are providing a value different from that which is initialized, then that new value is taken and used. The initial values are only to be used when there is no value provided inside the function call. When you call a function and do not provide a value, then the initial value will be revoked automatically. Okay, so this is so called, if in another word, if I tell you, this is a plan B. If you do not have something executable inside a function call, then the initial values which is predefined will be utilized. Okay, fine. I guess we are clear with all your answers and questions, and I hope this was a wonderful session. We'll be having the next session further from tomorrow onwards, and I'll be teaching you about HTML now, because the ultimate goal is for the Django part, to web development with Django. So Django you call, or you call it as a Django or whatever you call. I prefer calling it Django because I love that word D. D comes in my name as well. Okay, so we'll be continuing with Django tomorrow, and to come to Django and work with it, we must know how Python work, which I have told you in these two classes. Then we must also be knowing how HTML works, because web development is all about HTML in the basics. So we'll be starting with HTML tomorrow, and till then, keep learning, keep exploring, and thank you so much for attending this class.